These are the notes for chapter 7. These are slope. I'm aware that this does say section 5. We're going to go back and do everything we just decided this year to do it in a little bit of a different order. From the discussions we've had in class, slope is defined as the rise over the run or the rate of change. We can also call it the change in y, which is the rise of the y-axis, how much it's changing on the y-axis over the change in x. So what I'm going to do through the notes is ask you to fill in the blanks on your own and push pause and then come back to the video and check how you filled it in or maybe write some additional notes over it. So with that, I have some blanks filled in. Okay. And down here where it says a negative slope looks like, a positive slope looks like, I'd like you to just draw a sketch of what they look like based on the experiences you've had with the activities we've been working in class. So please push pause now and fill these in the best you can. Okay. So here are the ones I've filled in best I can. A horizontal line will have a slope of 0, and that's going to be based on you're going to have no rise, 0 rise, and your run could be any number, and 0 divided by anything is 0. Vertical lines will have a slope of undefined. If you think of it this way, their rise is infinity, or you could define it between any 2 points. And the run, or the denominator of the slope, is 0, and you can't divide by 0, so it's undefined. Slope describes the steepness of a line, so when we're talking about that and describing it as we did back in the polygraph activity, and you were talking about is it steep, it also describes the direction of a line. And by direction, I mean is it increasing or decreasing. So sketches for a negative slope and a positive slope. If the rise is greater than the run, the line is closer to vertical. And by the rise and the run, I mean the absolute value of those. And if the run is greater than the rise, the line is closer to horizontal. So again, think of it, if you're rising 10 and running 1, rising 10 and running 1, that's pretty steep. Where from rising 1 and running 10, rising 1 and running 10, in a consistent manner, it's going to be less steep. So over here, I have 4 lines. I'm going to move this around a little bit, hopefully. And to find the slope, what you're going to do is find 2 points. This just doesn't want to show you. That work for you. So, like for example, I would use this one because it's very clearly glowing through that point. I wouldn't choose one where you're estimating a fraction. Like this one over here would be a bad point. So you're going to choose 2 points on the line that are pretty clearly marked. Okay, if you have the printout, you can work through those, or if you have them on your screen. So I'd like you to try to calculate the slope of this black line here, the red line, the purple line, and the green line. These lines here mark the x and y axis, the black horizontal and the black vertical. So please try to find the slope now. Push pause. Okay. Now I color-coded and I kind of tried to show the points that I used. You could have used something different, but they should be pretty close. For the purple line, I used these two. It had a rise of 3 and a run of 0, and as we talked about, 3 divided by 0, you cannot divide by 0, so the slope we say is undefined. In the red horizontal line, it rose 0 from yellow to yellow, okay? So I didn't rise any, but to go from this yellow to this yellow, I ran 3. 1, 2, 3. I went over 3. And 0 divided by 3 gives me a slope of 0. You can see here on the black line, I marked the points I used. And then I wanted to see, it's kind of giving directions. How many do I need to rise and then run to get to the next point? So I started down here at -2, and I had to rise up to 7. So that's an increase of 9. And then I had to run, increase of 9, and then run 7. Because I went from 1 to 8. Okay, so here's the 1. I was over here at 1, and I went over here till 8. So that's a run of 7. And we right slope as rise over run 9 over 7. Down here, I chose these 2 points. What I decided to do was go from left to right. You can go the other way too. So I said I went down 1 and decrease of 1, and then I ran positively 4 spaces, so a negative 1/4. Now if you went the other way, you'd still get negative 1/4. You may also see it as rising 1, a positive direction 1, and then running a negative direction 4. So it could be 1 over negative 4, which is still a negative 1/4 slope. Okay. Over here I gave you 2 points and asked you to find the slope, and I kind of gave you 2 examples here of ways to do it. One way would be to do a quick sketch. Here I was at 4 or 4 comma 5 and 7 comma 9. I just kind of roughly sketched them. I didn't put the grid on purpose. And I used that idea we were just doing before. So here I am at 5, y coordinate of 5, and I have to rise to the y coordinate of 9. So it's a rise of 4. And then I went from 4 on the x-axis to 7 on the x-axis. That's a run of 3. So my slope is 4 rise over 3, slope of 4/3. Over here I did the same thing, it's just more mathematical. So I found the change in the y's. I went from 5 to 9, so I found the difference between those two. I went from 4 to 7, that's a difference of 4 and 7. I got negative 4 over negative 3, which simplifies to a 4/3 slope. So these slopes are exactly the same. I'm just trying to show you 2 different ways to look at it. I did one more over here where again I plotted them, if that makes sense to you, and I said okay, to get from one to the other, I started on the right side and I said I went up 1 to go from negative 1 to 0, and then went back 1 for a negative 1 slope. Again, you could do it 0 minus negative 1 and then 2 minus 3, and that still gives you the negative 1 slope. I want you to see that on example 1, I subtracted the y coordinate from the first and then the y coordinate from the second. I went backwards in the second example. It doesn't make a difference which one you do, as long as you're consistent in whichever point you start with the same x coordinate. So if I start with the 5 and I subtract 9, that means in the denominator I have to start with the 4 and subtract the 7. If I start with the 0 and subtract the negative 1, that means I have to, in the denominator, start with the 2 and subtract the 3. So both these methods give you the same answer. It's more of what makes sense to you. So here are 3 more problems for you. I'd like you to push pause and calculate the slope. You can either do it kind of this sketch method or with finding the differences of the y coordinates over the differences of the x coordinates. So please push pause now. Okay, the answers to these problems are here. I just showed it the one method. You should be getting the same method. If you're not, please see your teacher and ask them the questions that you may have. So negative 4/3, 0, and undefined. If you plotted these points, you would see these actually make over 3 up 5 over negative 2, make a horizontal line, and these two make a vertical line. So it does make sense that their slope should be 0 and undefined. So in this matter, we're given a bunch of points in a table, 0, 0, 0.5, and 3, 1, and 6, 1.5, and 9. So you could plot all those points. And what I want you to do is find Laura's rate of change, which is the slope. So again, use the method that you would like to use, and then talk about what does that mean. So push pause, try that. Okay. What I did here is I found the difference between the y's, the distance, so 3 minus 0, and 0.5 minus 0, and 3 divided by 0.5 is 6. And then I wanted to show you that it really doesn't matter which set of points you pick, so I picked a different set. I said, okay, well, how about if I pick these 2 points? 6 minus 0 over 1 minus 0. And that still gives me 6. And you could try this, any 2 points. You could pick 9 and 0. 9 minus 0 over 1.5 minus 0. That's going to give you 6 again. You could try 6 minus 3 over 1 minus 0.5. That's going to get, no matter which one, there is a constant rate of change. So we'll always simplify down to the same thing. Now, what does it mean? Well, the difference in the top was the difference in miles. Okay? Remember, 3 miles minus 0 miles. And what were you finding the difference of in the denominator? Time or hours. So what this is saying is her distance will increase, because it's positive, 6 miles per hour driven. Or she's going 6 miles per hour. In the next one, it's the same idea, but now we gave it to you in a graph. So you can pick your points. Again, look for them to go through the corner. So it's a good point. It's not an estimation point. And also, please be careful. Look at the boxes here, at the way that we numbered these, because they're different than what you think. They're not just all labeled one. So please try this and then label what it means. Here are the answers to those. This went down 6. Notice I was at 17 and I went down to 11. I was at 29. I went over to 89. That's why I said be careful. And that is negative 6 over 60, or negative 1/10. And what does that mean? The gas in the tank, the gallons in the tank, that's what I was measuring in the rise, decrease 1 gallon for every 10 miles driven. And again, I figured that out because my rise is talking about gallons and my run is talking about miles driven. So that concludes the notes for slope.